Okay, so this is how I would save time on the polynomial test. These are just some tricks that I saw that is probably easier than what a majority of the people would do. So for the first one, and by the way, I have the number and which poly homework it came from for reference if you want to try these on your own. So for this problem, we have to divide this by this. And so one thing that I think is faster is doing synthetic division twice. So if there's a 1 here, right, we can probably, and this is factorable, so x minus 2, x minus 1. We can do we can do synthetic division twice. One with 2 and one with 1. So that I'm just going to rewrite this with the 2, and we can just go through it. So, right, normal stuff, right, and this is the remainder, and then we do next with 1. Right, and so here this would be 3x squared plus 7x plus 10, but what would this one be and what would this one be, right? So if you think about it, right, this one is x minus 3 over, this one is 3 over x minus 2, right? But then we had to divide it by x minus 1 again. So really, this is 3 over x minus 2 times x minus 1, right? Whereas this one is just negative 11 over x minus 1. I'm pretty sure Mr. Park will let you write your answer as these two fractions separated. As if you do it the conventional way of doing long division, you would just get this, but with the fractions combined. For this one is just a small thing that I know. So if you have two different roots and you look at the first number and they're the same, if you think of when we do reverse CTS, so like here we would do x is equal to 1 plus 2i, x minus 1 is equal to 2i, and then you square both sides to get x minus 1 squared is equal to negative 4, right? And then you do x squared minus 2x plus 1, and you add the 4, right? And then here you also do x is equal to 1 minus root 3, x minus 1. I'm going to skip some steps here. X squared minus 2x plus 1 minus 3 is equal to 0. If you look at the expressions that we get, so on the left hand we get plus 5, and on the right we get x squared minus 2x minus 2 equals 0. We'll have to multiply these together, right? And so I'll just move them together and erase the equals 0. Here, if we have to multiply them together, instead of just going term by term, right, going this times this times this times this, yeah, let's, if you look at the x's, right, if you look at the x's, we can actually do a u substitution to make this easier. So let u equal x squared minus 2x, then we'll get u plus 5 times u minus 2. Foil this, you get u squared plus 3u minus 10 is equal to 0. And doing this squared is very easy, as we can factor this as x times x minus 2. And then if we square that, right, we should just get x squared times x minus 2 squared. And so when you're distributing this out, all you have to do is you think, oh, this will be the coefficients of x minus 2 squared, but then it'll be to the fourth power, third power, and then second power, right? And so we know that the coefficients of x minus 2 squared is 1, minus 4, and 4, right? And this is the x squared term. And then plus 3u, so plus 3 times x squared minus 2x, right? And so that'll be 3 on the x squared, and then minus 6, and then minus 10. And so look how easy that is. 1 minus 4, 7, negative 6, negative 10. And then all you have to do is combine that. This looks wrong. Yeah, this is wrong. Okay. Sorry, this negative 10. Yeah, this. Okay, yeah, wait, no. I was correct. Yeah, so x to the fourth minus 4x cubed plus 7x squared minus 6x minus 10. And that's your answer. Okay, there's this other example in Poly 6 where we have the same thing. I'm going to do this quite fast to show you guys what I try to do in my head. So, to be honest, for the longest time, I was just doing this in my head. And this is really, just being able to do this in your head is good. And then distributing while minusing is also a good habit, right? But of course, if you can do this all in one step, that's good. So x squared minus 4x plus 1 and x squared minus 4x plus 5. I know that that's going to be u plus 1 times u plus 5. So u squared plus 6u plus 5. Squaring x squared minus 4x, which that's going to be x squared times x minus 4 squared. So it's just going to be 1, negative 8, 16, and then 6 times x times x times 6 times x minus 4, or 6 times x squared minus 4x, right? So 6, negative 24, and then plus 5. Combine this, right? That's your answer. And then this should be the fourth part. X cubed plus 22x minus 24x plus 5. And that's your answer. Okay, Poly 5. The new roots questions, if these are all the same, okay, if they're the same variation of the roots, right, then there's always going to be a trick with it, okay? There's always going to be a trick with it. So, and then for C, I'm going to make this, instead of find the value of a squared plus b squared plus c squared, I'm going to make this roots a squared, b squared, and c squared to make a better example. So a minus 1, b minus 1, c minus 1, if you think about that, the roots, right, were all just moved 1 to the left, right? And so that's the translation of 1 to the left. And so we plug in x plus 1, right? We do the translation x to x plus 1, okay? And then you do x x plus 1 cubed plus 3 times x plus 1 squared plus 5 times x plus 1 plus 7 equals 0. Okay, so this will be 2 times, I'm just gonna do coefficients, so 1, 3, 3, and 1, plus 3 times 1, 2, and 1, and then plus 5 times 1 and 1, and then 1. Okay, so we get, I'll do this over here. This is quite space intensive. 2, 6, 6, and 1. Then we get 3, 6, and 3. And then we get 5 and 5, and then we get 1. So 8, 10. So this is 10, 12, 17, 9, 2. So yeah, that's it. It's x, so we get 2x cubed plus 9x squared plus 17x plus 10 equals 0, and that's it. Now, if we have roots a squared, b squared, and c squared, this is a bit more complex, right? As this is not just one translation. But really, what we do for x is we make x go to the inverse of the function happening to the roots of the roots, okay? So in this case, a minus 1, what is the inverse of this? Let's call this y. And let's call this, what's the inverse of this? Well, we have to switch our variable, and then we get y is equal to a plus 1. This is the inverse, right? And so we wanted a plus 1, right? And so, yeah, we would plug in x2, x plus 1. Now, if we look at a squared, right, is equal to y. If we switch it, goes to a, y is equal to the square root of a, right? And so here we want x goes to the square root of x. Let's plug in, right? And so this is the translation that you want. Now it's a bit more complicated as you'll get a bunch of square roots for this one. But let's do another example. What if it was like 2x minus 3, right? What if that was the translation? Or, sorry, 2a minus 3. Let's switch it, right? A plus 3 times 1/2 equals y. And that's the inverse. You would do x to 1/2 x plus 3. Okay? So yeah, that's the idea. But just know that even if you do the inverse, you'll still need to make it into polynomial form, okay? And so when we do this x2 square root of x for this one, let me clear this space over here, okay? If we do x2 square root of x, we would get 2 times the square root of x cubed plus 3 times the square root of x squared plus 5 times the square root of x plus 7 is equal to 0, right? Here, if we look at this, this becomes 2x root x plus 3x plus 5 root x plus 7, right? This is not in polynomial form as we have roots. So here, what we do is we have to isolate the roots, right? So let's put 2x root x plus 5 root x together, and then let's put negative 3x plus 7 on the right side. And then on the left side, I'm going to factor root x out, okay, to make it easier on myself. 3x plus 7, and then I'm going to square both sides, okay? So let's square both sides. Square, square, So here we get x times 2x plus 5 squared. Okay. And then on the right side, we're just going to get 3x plus 7 squared. Okay. And then let's keep on going. So on the left side, we get 4x squared plus 20x plus 25, and that's all times x. And that is equal to 9x squared plus 42x plus 49. Okay. And then we distribute 4x. I'm just going to do this. So we have to minus this on the other side. So I'm going to try and do this. I'm going to do this in my head to save steps and less writing. So in the x cubed, this is all going to be 1 degree higher. So this will be 4, 20, 25, right? But this will be the x. So this is 9, 42, 49. Okay. And so we should get 4x cubed plus 29x plus 67x plus 49, and that's equal to 0. And that's our answer. So yes, quite complicated, but yes, you do have to get it into radical form. I think the most he's going to do is a squared, b squared, and c squared as the cube root, as a cubed, b cubed, c cubed. That would be messy. But you still could do it. More examples. Okay, 2a plus 1. 2a plus 1 is equal to y. And then if we isolate a, we should get the inverse of function. So a y minus 1 times 1/2, right? So 1/2. And yeah, 1/2 y minus 1. That's basically it. So yeah, here you would do x to 1/2 x minus 1. And you would have to work that out. And yes, the 1/2 also gets squared. Also is put into the power. So for the first one, it would be 2 times 1/2 x minus 1 parentheses cubed. So yeah. So this would become 2 times 1 over 8 times x minus 1 cubed, right? And then we can make this 1 over 4 and stuff like that. So yeah, you'll just have to keep going on doing that through all. Next, 1 over a. Let's make that equal to y. The easiest way is just to reciprocate both sides. So a is equal to 1 over y. And yeah, so here we just want x to 1 over x. Now, if he ever puts this problem on the test, 1 over a, 1 over b, 1 over c, if we plug this in, right, into our original, we would get 2 times 1 over x cubed, right? But what is that? That's just 1 over x cubed, right? Plus 3 times 1 over x squared, right? But what is that? That's just 1 over x squared. And the pattern keeps on going, right? But we need this in polynomial form, so we multiply each side by x cubed, right? And so this will mean that x cubed times 7, this would be the highest power. Similarly, this would be the second highest power. Then it would be a 3. Then it would be the 2, right? And if you look at this answer, where have I seen this from, right? Oh, well, that's just the original one, but with all of the coefficients flipped. So yeah, if you ever see 1 over a, 1 over b, 1 over c, just go ahead and look at the answer and write down the coefficients but reverse. And that's free. That's free. Okay, now okay. So these kinds of questions are going to be on a test. Okay? And you need a strategy for this that's not just guessing and checking, right? of course, and so yeah, here's what I'm thinking of, okay? Here's something that I learned uh, from researching, okay? Look at your polynomial from in descending order, okay? How many times does the sign change? If you look at this is positive, negative, so that's one change, okay? It's still negative, still negative, still negative. Now, what does this 1 represent? This 1 actually represents the number of positive roots, okay? So, if you look at this, right, there's 4 possible roots in this equation, and only one of them is positive. So where should you be looking? Well, if you want to find them, normally 3 out of 4 chance it's gonna be a negative, right? Then we can try then what I would do is I would normally just guess in the middle. So -3, -3, and then if we do long division here, -31, -15, 2, -3, -4, 12, 9, -27. Here, I stop, okay? Because here, if you think about it, this will be a large negative, right? And then multiply that by 3, we get a large positive, and that overpowers the -15. So we still get a large positive. And so this does not equal to 0, so it's not a root. But what do we get? This is positive, this is negative, this is positive, this is negative, this is positive. So -3 is the lower bound, right? Right? And so that's another strategy, using lower bounds and upper bounds to your advantage. So yeah, keep on going. So if this is the lower bound, keep on trying. There's -1, there's -1/2, and then yeah, there is 1/2 that you could go. There's 1/2 that you could do, and then you could keep on going up, right? But because only 1 out of 4 of the roots are positive, it's probably likely that it's negative. Okay. When a polynomial p of x and the okay, yeah. So this is a very quick one, but when we have p of x is divided by 2x plus 1, and we're giving the quotient and the remainder, how you set your problem up is we have to do the reverse. So p of x over 2x plus 1 is equal to our quotient, right? Our quotient and a remainder. So 3 over 2x plus 1. What we do is we multiply both sides by 2x plus 1, right? And so we get p of x is equal to q, our quotient, times 2x plus 1 plus 3. Now that's the proof on why. To set up this problem, you just do 2x plus 1 times the quotient, and then you have plus the remainder, okay? And it goes like this. Divisor times quotient plus remainder is equal to p of x. So yeah, just do this times this, just do this times this, plus this, and that's all you have to do. Okay, yeah, that's basically it. Most of the word problems will be straightforward. Mr. Park loves to put on geometry in his problems, so remember your 30, 60, 90s, your 30, 60, 90 triangles, and remember similar triangles. So I think 30, 60, 90s are most of what he does. Similar triangles is probably not on the list. So yeah, remember 3069 triangles, and I'll do it, or yeah, yeah, like that. Just do that. 3069 triangles. Okay, bye.